Ever watch someone who's just like a total master at what they do?
Wow.
A chef, maybe, or a musician?
Oh, yeah, absolutely. Or even, someone spotting a tiny detail really fast.
Exactly. So like in a spreadsheet or something.
Yeah.
Haven't you ever wished you could just sort of see what they're seeing, focus on what they focus on to learn it faster yourself?
That's a really common feeling, I think. We all want that shortcut, right? To
Mhm.
learn by watching the best. It really just shows how much we learn visually.
It really does. Well, today on the deep dive, that's kind of what we're digging into. We're looking at something called eye movement modeling examples, or MMEs for short.
Right, Emmys.
Think of it as getting a proper research-backed look at how literally seeing through an expert's eyes can help you learn stuff faster, perform tasks better.
And we've really gone deep on this one. We've been working through a huge review published in Educational Psychology Review.
You're just right. What was it, 72 studies?
Yes, 72 studies, which actually covered 78 separate experiments. So it's a really robust overview. And what's cool is it pulls from all over, not just education, but sports, medicine, aviation, tech. It's broad.
Yeah, exactly. And that's why this is so useful for you listening.
Yeah.
We're cutting through the jargon to see how these, gaze visualizations can actually help you learn.
A practical shortcut, potentially.
So our mission today is basically to unpack all this research, find the most important bits, maybe some surprising things too, and see how this seeing is believing idea can actually work in practice.
Sounds good. Where should we start?
Okay, let's start right at the beginning. What exactly are these MEs and what do they look like? What are we seeing on the screen?
Okay, so at its core, an EME is basically an instructional video. Someone's doing a task.
Right.
But the key thing is there's this overlay, this visual graphic showing exactly where their eyes are looking while they do it.
So it tracks their gaze.
Exactly. It's like having a pointer showing you what they're paying attention to, moment by moment.
Okay, so if I'm watching, say, a surgeon operate, I'd see a little dot moving around on the screen showing where their eyes are focused.
That's a perfect way to picture it. And there are basically two main ways that gaze is shown.
Okay.
The first one uses what they call scan paths. Imagine seeing little dots or circles pop up on the screen.
Uh-huh.
Each dot is a fixation, a brief pause where the eyes are taking in info. Sometimes bigger circles mean they looked there for longer.
Okay.
And then these dots are connected by lines showing the quick jumps between fixations. Those are called saccades. So the key thing with scan paths is they show you the order of looking, the sequence.
Got it. Like a trail of where their attention went, step by step. Makes sense. What's the other way?
The other main type is called attention maps. These don't focus so much on the sequence, but more on the areas of interest and how long they looked there.
How do they show that?
Well, often using heat maps, like weather maps, areas looked at more get warmer colors, reds, oranges.
Right, I've seen those.
Or sometimes they use a spotlight effect. The bit they're looking at is clear and bright, and the rest of the screen might be like blurred or darkened out.
Ah, okay. So scan paths show the journey. Attention maps show the destinations, kind of. The important zones.
That's a good way to put it, yeah. Journey versus zones of focus.
And the review mentioned static versus dynamic visualizations too. What's that about?
Oh, right. That's pretty simple, really. Static just means you see the whole pattern at once, like a single image showing the entire scan path or heat map after the task is done, a summary, basically.
Okay.
Dynamic is what you usually get with video MEs. The gaze visualization unfolds in real time with the video. You see the dot moving or the spotlight shifting exactly as the performer was looking.
So dynamic is watching it happen live, almost. Static is the after picture.
Exactly.
I remember seeing figure 1 mentioned in the review too. Did that just show examples of these?
Yeah, it was super helpful. It showed a picture of that spotlight attention map,
Yeah.
Dark around the edges, clear focus area. And then it also showed a scan path with the blue dots for fixations and the lines connecting them.
Right.
Seeing them side by side really makes the difference clear.
Definitely helps to visualize the visualization, doesn't it?
Yeah.
Okay, so we get what EMEs are now. But why do researchers think this works? What's the theory behind why watching someone's eye movements helps us learn?
Well, the review points to three main reasons, three rationales. First one is pretty straightforward, guiding attention.
Okay.
Think about complex visuals or things happening quickly. It's hard to know where to look, right? Someone explaining verbally helps, but words can be ambiguous or maybe not timed perfectly with the visual.
Yeah, like trying to describe exactly where to look on a busy screen.
Exactly. So the EME acts like a very direct visual cue. It literally points to the relevant stuff at the right time, helps you filter the noise.
So it's like a built-in highlighter for your attention.
Precisely. The second idea is about illustrating expert strategies.
How so?
Experts often develop these really efficient ways of seeing and thinking, perceptual strategies that they might not even be consciously aware of.
Right, it becomes automatic for them.
Yeah, like that bird watcher you mentioned, or a skilled mechanic diagnosing an engine sound. Their gaze patterns often reveal these hidden strategies, maybe a systematic search pattern, or focusing on one key spot before acting, like the quiet eye in sports.
Oh, the quiet eye. That steady gaze before the shot.
That's the one. MEs make these often invisible or tacit strategies visible so a novice can see it and potentially learn to do it too.
So it makes the expert's seeing process learnable. That's really interesting. What's the third reason?
The third one is about social learning. It's a bit more subtle.
Okay.
The idea is even watching a video, seeing where another person is looking, creates a kind of social presence, a feeling you're learning with someone.
Even though it's just a recording.
Yeah. It taps into something called social agency theory. Basically, social cues, even subtle ones, can make learning feel more engaging, maybe make you process it more deeply. It's not just what they look at, but the feeling of observing another person doing it.
Interesting. So it leverages our natural tendency to learn socially. Okay, those three make sense. Guiding attention, showing expert tricks, and this social element. Powerful stuff. Now, where are people actually using these EMAs? What fields are big on this?
The review really showed a wide range. The big ones were sports and PE, definitely. Then medicine, lots of applications there. Aviation, too. And then a whole bunch in STEM fields.
STEM-like.
Programming, math, physics, biology, quite varied within STEM itself.
Okay, that's a pretty diverse list. Did the review find that the reasons for using EMBs were different in these fields? Like, was medicine using it for the same reason as sports?
It seems like the emphasis changes a bit, yeah. In sports, like we said, there's often a big focus on that quiet eye, identifying it, training it.
Right, for performance.
Whereas in medicine, while they definitely want to show expert strategies, say in reading an x-ray, there's also a really strong emphasis on guiding attention, making sure trainees don't miss critical visual details.
Which makes total sense given the stakes in medicine. You can't afford to miss things.
Exactly. And then in the STEM fields,
Yeah, what about STEM?
it seemed a bit more mixed there. Guiding attention and showing strategies were still important, but they also seemed to mention the social learning aspect more often.
Why do you think that is?
Maybe because the tasks can be quite abstract, like watching how someone visually works through a complex problem on a screen. Maybe seeing their gaze makes that cognitive process feel a bit more concrete, more connected.
That's plausible.
Yeah.
Like getting a peek inside their thinking process via their eyes. It also mentioned different names being used, right? Like quiet eye training. Are these all just MEs with different labels?
Pretty much, yeah.
Wow.
Conceptually very similar. ME is common in educational research, but you see other terms. Quiet eye training often uses gaze feedback as part of the training. You might also see gaze-based training or visual attention training. Different fields, slightly different jargon, but the core idea using visualized gaze for learning is usually the same.
Got it. Different names, same game, basically. Okay, so if you're designing one of these or choosing one to learn from, presumably the design matters a lot. What did the review say about how variations affect how well they work for me, the learner?
Oh, definitely. The design choices are crucial. One of the biggest factors they looked at was the learner's prior knowledge.
Okay, so does it help beginners more or experts?
The evidence points pretty strongly towards beginners. People with little or no prior knowledge seem to get the most benefit. I think the number was around 72% of studies with novices showed positive effects on immediate learning.
Wow, that's quite high. So if you're new to something, seeing where the expert looks is really helpful.
It seems so. But then you get this thing called the expertise reversal effect.
Right, you mentioned that. What helps a beginner might not help or could even hurt an expert.
Exactly. If you're already skilled, you might have your own efficient ways of looking. The EMA's guidance could just be redundant or even distracting. It might interfere with your flow.
That's super important. Tailor the tool to the learner. What about the task itself? Does it work better for certain types of tasks?
Yes, absolutely. It seems most effective for tasks where the visual part is really central.
Right.
Things like visual inspection, checking for defects, reading medical images, or tasks involving coordinating vision and movement, so visuomotor skills like surgery or sports, also seems good for understanding complex visual information like diagrams or data displays.
Okay, that makes intuitive sense. If seeing is key to the task, seeing where an expert sees is helpful. What about tasks that are less visual, like math problem solving.
So yeah, the review suggests it might be less effective there. If the critical steps are more about logic or calculation and less about spotting something visually, then just seeing where someone looked might not add that much value. The solution path might be clearer from their actions anyway.
Right. Seeing someone look at numbers on a page doesn't tell you how they're manipulating them.
Okay. And we talked about scan paths versus attention maps. Did the review settle which visualization type is better?
That's still a bit up in the air, actually. Most studies use dynamic scan paths, the moving dot.
Okay.
There isn't a ton of research directly comparing them head to head. One study suggested attention maps might be better, maybe less visually cluttered. But another study found scan paths might have a slight edge, especially for static images. So the jury's still out.
So no clear winner yet. Maybe it depends on the specific situation.
That's what the review suggests. The best choice might depend on the task. Is it static? Is it dynamic? Maybe even what the learner prefers. We need more research there.
Fair enough. What about the person in the video, the performer? Does their expertise matter or how they act?
Yes, definitely. The review found a pretty clear trend. MEs with more experienced performers generally lead to better learning.
Makes sense. Their gaze is probably more efficient. Likely, yeah, they're modeling better strategies. But here's something really interesting, how they behaved.
Oh.
EMEs, where the expert was just told to perform the task, naturally seem to work better for immediate learning than ones where they were told to act like a teacher, be didactic.
Really? That seems counterintuitive. Wouldn't you want them to be trying to teach?
You'd think so, but maybe the natural performance shows the real, authentic, maybe even subtle visual habits of an expert, whereas trying to teach might make them oversimplify or focus on things differently than they normally would, maybe hiding the real expert process. It's a really fascinating finding.
Yeah, that is. Sometimes the raw, unedited version is better. Okay, one last design thing. What about adding other stuff like audio commentary or showing the mouse cursor? Does that help or hurt?
It seems like it can sometimes reduce the unique benefit of the EMA itself.
How come? Redundancy.
Yeah, potentially. If the audio is already telling you where to look or the mouse is pointing things out, the gaze dot might not add much new information. It could even lead to cognitive overload, that split attention effect, trying to process too many cues at once.
Right, so more isn't always better. You need to make sure each element adds something unique.
Exactly. Careful design is key.
Okay, this is great. We've covered what MEs are, why they might work, where they're used, and how design matters. Let's get to the results. What are the actual outcomes? Do they really improve learning and performance?
Right. The bottom line. So first, the review makes this important distinction between performance, doing the task while watching the EME, and learning, being able to do it later on your own.
Okay, yeah, that's crucial. Following along isn't the same as actually learning it.
Exactly. And most studies the review found have focused more on immediate learning outcomes, like tests right after watching, or changes in the learner's own gaze patterns.
Less on long-term retention.
Less on delayed learning, yeah. And also less on measuring performance during the EMA viewing itself. Those are areas needing more research.
Gotcha. But overall, what did the studies find? Positive effects.
Generally, yes. Most studies reported at least some positive effects, either on learning or performance, or both. So it does suggest that, when used well, MEs can be a valuable tool.
That's good to hear. But didn't you mention something odd about gaze measures? Like, no studies found negative effects on gaze.
Yes, that was interesting. No study reported that MEs made a learner's gaze patterns worse. But the researchers add a big caveat here.
Which is?
You kind of have to decide beforehand what good or expert-like gaze looks like for that task. It's possible some studies just observed any change in gaze after the EME and called it positive, without maybe a strong theoretical reason why that change is actually better.
Ah, I see. So just because my eyes move differently doesn't automatically mean I'm seeing things better, unless we know what better looks like for this task.
Precisely. And it's also key to remember, while no negative effects were reported for gaze behavior, some studies did find negative effects on actual learning outcomes.
Right, like we talked about if it's redundant or causes split attention.
Exactly. It really hammers home that MEs aren't magic. They need to fit the learner and the task.
This has been incredibly thorough. So let's try and wrap this up. For someone listening, what's the main takeaway message from this deep dive into ME research?
I think the core message is that Emmys have real potential. They can genuinely help you learn by guiding your attention and showing you those expert visual strategies that are normally hidden. And this applies across a whole range of different skills and fields.
But it's not a magic bullet, right?
Definitely not.
Hmm.
Its effectiveness really depends. It depends on your prior knowledge. It depends on the task. How visual is it? And it depends on the EME's design, the visualization type, the performer, other cues. All those things matter.
So now that we've sort of looked through the EME research lens, here's a thought for everyone listening. Think about your own learning goals. Where are you trying to get better at something? How could seeing exactly what an expert focuses on change how you practice or learn? What tasks in your life might really benefit from this seeing is believing approach?
That's a great reflective question. And if you are curious, maybe do a little digging online. Search for eye movement modeling examples, plus your field sports, programming, art, whatever it is. You might find something already exists that you could use.
Good tip. See if you can find a way to leverage this for your own goals.
Absolutely. And, the research is ongoing. We'll likely see even smarter, more personalized email designs in the future, making this kind of observational learning even more powerful.
Fantastic. Well, this has been fascinating. Thanks for joining us for this deep dive.